Welcome everyone to this MD2K webinar. Today's speaker will be Dr. Jon Moon, who is President of MEI Research. Dr. Moon has his Ph.D. in Biomedical Engineering from the University of Texas, and his company develops technology solutions for behavioral and broader health research. And today's webinar is going to look at the process of finding or creating technologies that meet the needs of a research project. So with that, I will turn it over to you, Dr. Moon.
Yeah, thank you, Barbara. And I think this is an important topic. It'll hit people most usually when they're in the midst of something. So I'm glad you're going to post this online. People then might see it when they're really thinking about it. Of course, we're here because mobile sensors, point-of-care diagnostics, and mobile-enabled data really are giving us a tremendous change in healthcare and our knowledge of physiology and psychology, particularly at the individual level, where we're going to understand and influence behaviors. So some of you have had to create your own technologies or put them together in a package. For the rest of you, I'd expect that you're going to have to do that at some point. So this and the other MD2K webinars should be a great resource. I'd like to thank Barbara, who already introduced me, Professor to do this, and Dr. Dana Wolf-Hughes, who made the initial connection for this seminar to make it possible. And a particular shout out to the prior presenters who are saved on the MD2K sites. And they are a huge resource that I'll try to point at appropriate places in this talk. As Barbara mentioned, I own a company. I think it's fair that I give you disclosure that we do build the kinds of things that we're talking about here and make a habit of supporting researchers from early stages. So when you first look at it, an effective health interaction can seem quite simple, even those that effectively form new behaviors or habits. In this example, we have three components regarding medication adherence. One is to enter information and a reminder of when you would like to be reminded to take it, a question as to whether you actually took it, nothing burdensome about that. You enter the data and record it. It could set up another reminder or change the reminders later, but it can also incorporate an actionable portion of the message, such as in this case, leading someone to a location to refill the medication, or perhaps to a clinic, something like that. So this looks fairly simple, but even something at this scale probably will end up, at least these days, requiring some software to be developed. So the purpose of this presentation is to help you get from realizing you have a need for tech to realizing the technology itself. I've been in did wearable sensors decades before that, but the turning point now is our ability to intervene effectively to influence health behaviors and form habits. We've been developing projects like this since 2008. And the interest seems to rise exponentially, but that doesn't mean it becomes any easier. The majority of clinicians and health researchers we're involved with don't have the ready access that we'd like to see. And we need to give them tools to find collaborators, technology developers, or other resources. So this presentation will go through that in a bit of detail, touching deeply in a couple of places. And at the end, we'd like to make sure that you come out of it looking happier than when you went in. So why do I qualify to talk about this? Well, I've spent my entire life being a geek, sometimes formerly known as a biomedical instrumentation engineer. I've almost always worked with other researchers, and this has given me a chance to see many projects. I'd say over the last years, I've seen something on the order of 30 projects, either collecting data now or having wrapped up, maybe double that at the stage of putting a proposal together and writing grant applications that ought to have been funded even if they weren't. Sometimes things don't go well, and there are ways that's happened. It's hard to codify all of them, but we can give some pointers here, and I'm happy to talk to anybody anytime to give more detail. So it's hard to say that any of these methods, technology in your hands is will touch on some of the different aspects of making those choices. The first off, obviously, is you can do it yourself. Can be assembling it or actually teaching yourself enough to be building it. You can create or use an internal team at your institution. You can find a partner of some sort, or you can use a general technology like a development house and go out and find them. For doing it yourself, most often this means using some sort of off-the-shelf product, such as a Fitbit or SurveyMonkey, to scrutinize the details and the consequences of some of these choices. And you need to confirm that you have access to the data going in and coming out of these devices or systems. Could it be possible that you mention one or plan a budget for one and then your IRB has a problem with it? Is it possible that in a particular combination you would run into different personal information? Those things need to be worked through carefully as you're planning. Some of the benefits, of course, of off-the-shelf solutions are that some more and more are commonly available, especially in the physical activity space. It's possible to get heart rate monitors, various other kinds of sensors. Because they tend to be in higher volumes, they can be low cost, or they can be even free if the vendor happens to make their money in another aspect, such as concentrating and anonymizing the data. That could be something to worry about, though. They're available now, meaning quickly, which you would never get if you're developing it on your own. They've worked out ways to make it simple. They have designed the user experience, the instructions, and so on to get you there. And they have a lot larger user set, so that problems that cropped up have been worked out. The bugs have been addressed, in other words. To reach such a broad audience, some of the sophistication is limited. You won't be able to contact them for support, for customizations. You may not have the kind of data you need to validate the solution, or even without checking in advance, you may have limitations on getting enough resolution on the data. And particularly, there are experiences where these things, they are commercial products and they have to make money, and things can happen. Here's an example of a senseware that is no longer available. The same thing happened with, we've seen the Pebble watch that some people have depended upon. So can you use an existing technology? It's an evaluation problem. Some of it can be subtle. One example that I heard recently is that somebody wanted to do a mobile survey, and they didn't realize until they'd chosen the solution and nearly finished option for the participant to skip a question, which accorded in satisfaction. So you may need to look at that carefully You might have to actually pilot build it before you enter your proposal. Writing the proposal, you may need the help to secure that grant funding of a technology willing to write some further details. Is it possible that you will end up limiting your study, that you'll make compromises that will not address everything that you need? And practicing your data evaluation early might head that off, but certainly planning what the outcomes are going to have to look like in regard to the technologies that you're putting in is most important. So if an off-the-shelf, single, I emphasize that, off-the-shelf solution isn't available, are you up now for divining your own? Here's some background. This may be the bad news you didn't want to hear, but we'll get it out of the way in the beginning. Creating technology or even heavy customization can be expensive, and it may not be concentrated in the software developer hardware engineering time. It may be other aspects of the project, deployment, recovering equipment, having people teach participants how to use it. Certain publications project that researchers working with existing infrastructure or code libraries cost up to as much as a so you need to keep your expectations realistic. And it's impossible to plan for everything that might happen. It's possible by the time you get to your third or fourth project that your estimates will be within a few tens of percents. Until then, and especially on your first project, I would recommend allowing between 30 and maybe even 100% reserve funding against contingencies. So this may lead you to looking for separate and specific funding for the technology. An obvious direction for that would be the STTR, SBIR grants, things like that. So you have to look at what your trade-offs are going to be. Very rarely will you get all three of these, almost impossible. I certainly recommend trading off speed to get quality and low cost project. I have seen projects where they dive immediately into development because they're in a hurry. They realize their budget's limited, and they end up with no stools, no legs on the stool, and that approach is a failure. Developing an internal team is done more often than you might think. You can see several of the presentations here on the MD2K website from groups and their own work. I point to, for example, Eric Clare at UCSD, they're leaders in assembling a team and getting things produced that advance research. You might look at Eric's presentation for talent you would want to have on your team. Another way to go would be internal resources at your institution. This might be developers within the IT department, and you may have, for example, an office that provides REDCap or GIS services. Another combination might be from the biostatistics department and graphics designers. One project we helped deploy recently had students in the theater department produce education videos for medication adherence training. One caveat is that it's possible, and I've seen this, that your institution will require that you use internal resources that they have available. So you need to check that out in advance and see that you're free, what range of directions you're free to explore. Another approach is to find somebody who's actually partnering with you. These could be professors in engineering or computer science, a lab, public health school, even in the College of Design. It's something where you need smart tech style, or the extension program at your institution if you need to reach out. They will be, of course, interested in advancing their own research and gaining something from it. Some of these things can become complex faster than you think. This is a project that we're involved with right now. It looks like something that could be assembled from off-the-shelf resources, but it was very involved when we had to make sure that the sensors were synchronized, that activity signals from the wearable triggered patient interactions at the time windows, and by contingencies for displaying or acting on rules for the messages. This was coordinated by the two principal investigators and involved not only our company, but researchers at another university, the Actigraph company, and other people within the institution to handle data sets and monitor the results. So some of the benefits of having collaborators, just like you, they have the same interests. They want to see science advance, so they may pick up even more of the burden than you would expect. This increases the chances that they also already have technologies that you can adopt. But it could limit your choices if your project is in a field that is has a lower profile among the potential collaborators. A huge benefit is that they're in a different field and can in journals or talking at a conference that wouldn't otherwise be on your radar. Some of the downsides, and that means they may not be available at time of midterms. They're constrained to an academic calendar, especially things like graduating. Technology partners usually see their final outcomes at the end of development. I point you to the presentation that's from last year's mHealth Training Institute for some information and background on that. Finding potential collaborators, besides these webinars, I would look at people who present at conferences you attend, and a great upcoming opportunity is the Technology Showcase that will be at the NIH on June 4th. A good technology partner will try to what we call abstract the core or common technologies for you or others to reuse. Key example are app builders, where you're not writing a mobile app or mobile software from scratch, but you're configuring and filling content into something that deploys it relatively easily. These are often used for things like ecological momentary assessment or interventions. Another route to getting reuse capabilities is through application programming interfaces called API or sometimes hooks. They exist for wearable devices like Actigraph or inhalers, to individual data such as that compiled by Fitbit. There are a number of very useful functional data sets, meaning you have the back and forth exchange in the query for things like nutrition, geofences, engagement content, or one-way type information where you pull weather, traffic information or routes or dispersion of pollutants. And you can call on a lot of engines, the tools that are out there running on the cloud, such as to perform machine learning. There's a good overview of API in a presentation by Drew Mickelgard that I think you could find easily. He's the director of the Lighthouse Project at the VA and was presented under the OCE HRA project at the VA. In the app builders, you don't just fill in content, the images of drugs and so on, or web URL image, but they can almost act like light customization of software. Certainly they can apply decision rules, make those available to you, things like message skipping, we call it branching, piping, where you carry forward information. A lot of that should be available in a content managed app building setup. One of the key or one of the great applications of the app builders are behavior. And certainly Eric Heckler has talked about this, where increasing will be possible to make sure that the validatable social theories are expressed in these builders with regard to behavioral treatments. Another one that can be available fairly readily are location systems, where you have triggers for when people arrive or depart a certain location, certain kinds of tracks, and so on. And then the fourth place to get assistance would be from a general commercial vendor, and you may very well want to go this route. They have certain advantages. One of the biggest is they can create just about anything. It could be more expensive, even higher than what I mentioned earlier, but they have the capabilities to finish just about anything that they start. Another advantage is if it helps to be able to meet them in person, they're very likely to be local, whereas an academic partner may not be at your institution and you might have to engage them remotely. They have a deeper bench, we call it, so that they can put together a fairly large team. They can find other talent. They almost always use project management tools that you may not be familiar with and can help you through that. And they're used to providing commercial releasable designs that look polished. As we already touched on, they're likely to be more expensive. You may have to move further toward them in communicating your needs or the interests of research, and they don't look toward providing a continuum of progression in products or capabilities. So in fact, even with the same partner, if you go back to them again, their team may have changed and you have to take a couple steps back to work on the next project. So evaluating a tech solution can be difficult. Here are some of the things that I've heard that could potentially indicate that we're leading towards a failure. For example, but we're not sure about the rest. I have a lot of time. Or I'm a young investigator, I'm new to these kinds of projects. Can't you just help me get started and figure out kind of the rest because you're the technologist? So it's important that you have a clear and easily communicated description of what you really need. And we're going to talk about that next, before you get into communicating with particular people who provide you with technologies. And you need to, it doesn't hurt to share a lot of information. You might redact the grant application, add as much information, fill that out as possible. But you're going to have to be responsible for getting from the beginning to the end of the project. You are now the project manager, so you need to be prepared to devote the time and effort that it deserves. I'd suggest having some background or picking it up somehow in project management. There's some great books out there. A lot of excellent videos. You can pick some of that up from looking at the ones on this site, even further other places on YouTube. And then we often expand that into the expectations sections in our contracts. You need to agree in writing on what it is that will be produced and who's going to be performing what roles. Most often that comes out of being part of an agile or rapid iteration process. And I strongly recommend that communications be a key emphasis on what you're doing. You ought to drive those communications to make sure that everything gets completed. And then prepare for what's going to happen during deployment with a lot of testing. Almost consider having as much time and effort devoted to testing as you have for development in the first place. When we get an email that says the software stopped working on the participant's phone, almost always that sets up a back and forth with multiple rounds of, was that more than one participant? What kind of phone? When did it happen? Were they actually using the app that you think they were? Was the phone even on? Those kinds of things can happen. You need to be able to prepare to capture those and address them before somebody has a bad experience. So if you're going to launch into a project engaging a vendor like us, or particularly, or a general one, it pays to have an understanding of the process at your institution. And most of these steps are going to be there. I see them a lot, requiring a competitive bid or sole source justification document, registration of the vendor, then requesting a quote, and so on, until the outcome is a purchase order, which is actually the signal to the vendor to start. These can take quite a bit of time, particularly at the audit and IRB approval stages. You often would be well advised to get some at least preliminary IRB approval in case it impacts the scope of the contract that you're going to come up with. And then these things may actually have to be revisited for a modular budget or each year, and they can even change fairly frequently within an institution. Once you have the purchase order, or sometimes preliminary to that, you need a statement of work. It has some essential components. It's essentially explaining to the purchasing department what it is that they and you believe the institution will be getting for their money. It describes the overall purpose, what will be delivered, an explanation of the content of the deliverables, and what's going to be the run out on the rest of the project. How do you see all of the study through to the end? To get to the actual development, you need requirements, and they are not just some geeky thing, as I've heard them described, and they're not developed by describing your needs typically in terms of existing technologies. There is a presentation, I think it's quite good, by Jill Hayes from March last year on this site that provides a good overview of design thinking and problems that can arise from coming up with poor requirements and not having sufficient communication. There are some proven techniques to creating useful requirements. Without them, it's like starting an experiment without a hypothesis and running principal factor analysis on whatever results. With sufficient communications and the documented requirements, you aren't forcing the developers to make assumptions, which to meet a deadline they will do, or to have something that's prototyped. But whenever possible, you don't want them to be creating something based on their preconceptions or an assumption. And finally, developers will benefit from that background that we discussed earlier, and they then may have some good ideas that you would fold back in and make some alterations in a back and forth on the design process. The key is great communications, and that comes from the specifications, and these are individual things that not only describe what will be built, but often lead to a testable result. Something that looks like what you would have in the aims of your grant application. And then they could get down to the mechanics of requiring you to understand the difference between a native app or a responsive website. You'll need to consider your population in designing these things. A lot of young people expect an app to load within 2 or 3 seconds or lose interest and migrate away. You have to be aware that system vendors produce interim updates very regularly and whole new releases maybe every 15 months or so. And that app that was running could stop running. It may be obsoleted for older versions of the OS that you were expecting to have continue. And to transport your data. So that's something you may have to unlimited to Wi-Fi, not in most off-the-shelf apps, for example. Off-the-shelf apps often are designed with the idea that they're in front of the participant only briefly, and then so they have a much higher current drain than you might be expecting. So you have to be able to deal with that. And you also have to, there's a coming problem with the app stores scrutinizing apps much more closely than they used to. So we've been seeing a lot of apps rejected because they need a camera one time to make some detection, or they may access location or the microphone, and in addition to your IRB, that might be rejected by the App Store. You have to plan for the user interaction with the participant, and that may mean that you need to find and budget for a graphic talent, or you may need a private label app. That's where your logo, your institutional colors are presented, and for some sort of assurance and to avoid confusion with the participants, so that and then puts the app developer behind the scenes, essentially hides us. Do you know where you need to have decision rules applied? Can they be back on the cloud, or do you need to be free of any possible interruption of transport and push those rules down to the app itself? Do you need an engagement? You need to make sure that the person remains aware that your app is on the phone, or that it should be recording data from a wearable that you've asked them to carry around or put on their wrist. A lot of people will change phones every year, certainly within 2 years. Hardware, and you want to make sure that they migrate our app to their new device. And then engagement also helps to make sure that people are having a good experience with the program that you're trying to apply to them. It doesn't take much to have a good engagement. You can tell a story, you can give them input on how the app or your program should interact with them, and you can make the interactions quite simple. Now on to some of the nitty-gritty here. I know this can look scary, but the technology development portion of a project, you need to allow plenty of time for that. And here are some of the elements that play into that. Administrivia, courtesy of Professor Fameter, refers to the institutional contributions. This might even light on the testing phases, allowing just 2 of them for major pilot testing occupying a month. I would suggest even more of that. And don't forget continuing maintenance and support and troubleshooting through the rest of the project. Here's how you can come together with some of the tools that would help communicate with the people who are partnering with you. At the simplest form, just grab a paper and start sketching. You can probably draw better than you really think. It's one of the best multimodal tools out there. There are also things that are on the web or software that you can download that help you communicate your concept for not just the functions, but also the appearance and a lot of the subtleties that will be interacting with people. To me, is one of the keys to having a successful project, and this is a flow diagram where you can see that the initial presentation to the participants, the decision stages, any places where you need to repeat a prompt or where you need to remove it at the risk of causing dissatisfaction. I particularly like this project because this is a snapshot of one corner of the flow chart, but it really led to the success of this early project. So we've already talked about testing. I think that having and emphasizing that to a high degree is your greatest indicator of success. This is probably the most important portion of the talk, so I've saved it to the end. The best time to write your test plan is while you're compiling your specifications. Try to come up with adequate test elements for each of the specifications, again, just as you would when writing aims in a grant application. It's similar in organization to that grant application. Of course, to save time and effort, where possible, this saves your cost. It also shows things in context. Where you have the ability to see how they interact. The participants, if you get to the point of showing it to them early on, can give you much more valuable feedback. And there are a lot of good sources on how to come up with an appropriate test plan. I'd multiple rounds of testing. One of the great attractions of powerful computer, sensor, and communication device. A consequence is that you have less control over the range of devices and less control over the operating systems and software, but it does give you an opportunity to get feedback from them. So I suggest putting a question or an opportunity to give feedback or collect feedback from participants in every application that you put out there. This does a lot of things. It lets you capture information early. It could be as simple as a small survey question at the end of a couple of the shorter surveys, maybe once a day. It gives people more satisfaction. It gives them the concept that people are hearing them and that you might be more responsive to their needs. But be prepared to test for errors and apply fixes regularly after the study starts. This will not be a one-time thing. And when you are collecting these error information, consider asking for, they're out there, or coming up with your own reporting form or checklist, both to obtain information from the participant when you're talking them over the phone, and to pass back to the people who are assisting you with the technology. Finally, a lot of app logs exist in these customized apps. We can tell, without violating participant privacy, we can tell things like what's the charge state on the phone, what's the operating system level, when was the app last opened, did it crash, did something else occur at the same time. A lot of these things are great for troubleshooting and can be captured automatically and aren't a lot of burden in the background. So that's a quick overview of how to get technologies developed. Feel free to contact me at any time. There's my email address. And I think, Barbara, are we good enough on time to take some questions?
Yes, we are. If anyone has any questions for Jon, you may have to unmute your microphone.
Yeah, it looks like it's still muted. There's also a chat function that you can type a question in.
Does anyone have any questions for Jon?
One thing then, if we don't have any immediate questions, is there's aspects of this of dissemination. That's often been a requirement in the past, where it's been interpreted as making a subset of data, often anonymized, available after the completion of a study. That's migrating and evolving, such that more recently dissemination is coming to mean something closer to commercialization, where there's an expectation from some of the funding agencies or from your colleagues that something you've created for your project, be it an app or a wearable sensor, be available to them as an operating capability, that they'll be able to download it from somewhere. Or even that the straight up commercialization, where a funding agency will expect to see more from their funding input than simply the result of data. And I do mean commercialization. I've seen early phase grants where that's actually been explicitly expectation. So you need to, when you're planning, consider that you will have to come up with a configuration that has greater longevity, and you would want that for yourself. Chances are that you will receive further funding in this area and want to prepare your app or your wearable in a environment where it could be picked up again and reused or adapted and advanced without starting over.
Okay, well, if no one has any questions for Jon, I guess we will wrap this up. Thank you very much, Jon. It was a very informative talk, and I really appreciate you taking the time to do
Thank
it.
you for the opportunity. It was great.